Hey guys, welcome to my channel. So in this video we're going to look at the famous Fibonacci series and also various methods to code the same, right? So let's go ahead and start defining what are Fibonacci series. So the slide basically says it. I'm just going to say it out loud. Now, any mathematical sequence that is formed by the addition of the two preceding numbers is called a Fibonacci series, right? So that is very simple to understand. Now we're going to go ahead and go to our whiteboard and try to understand it in a more mathematical format, right? With the mathematical notation, right? So Fibonacci of n, we use the capital F generally. Fibonacci of any number n would be equal to the Fibonacci of, as I said, two preceding numbers, right? So n minus 1 plus Fibonacci of n minus 2, right? So that is basically what Fibonacci numbers are, and this is the recursive equation for this. So any sequence formed by this equation is called a Fibonacci series. Very simple. Now let's go ahead and try to implement the first method or the first solution that we have in here, which is the recursive solution, right? So it is very easy to implement, and it's not the most time efficient algorithm, I'll tell you. It's the time complexity of this algorithm is 2 to the power n, which is not very good. And you might want to look for a better solution, which we are going to discuss in the later parts of this videos, right? But for now, we have to implement it, and before this you would need to have some kind of recursive or recursion knowledge, which you might want to acquire if you don't have already through my videos that I have on the recursive series, right? So please go ahead and watch those videos before you try to implement this part of the video at least. So let's go and try to implement it now. So let's call it the fib, and it will take argument of n, and then what we're gonna do is we'll need to have the base case. So we know that Fibonacci of 0 is 0 and Fibonacci of 1 is 1. So these two numbers are efficient or almost sufficient for us to get any kind of Fibonacci number, right? So if fn is equal to or less than 1, just return n. So we're just taking care of 1 and 0 at the same time, right? Or else, I mean, we don't have to say or else, we just can return Fibonacci of n minus 1 added with Fibonacci of n minus 2. So it was the same thing that we did in the whiteboard, right, previously. So yeah, because that was a recursive equation too. So what this is saying is, for any number, for any fib of n, we need fib of n minus 1 and fib of n minus 2. So for that, if we don't know what fib of n minus 1 and fib of n minus 2 is, we're going to basically call the functions over and over again until we get these two values, and then we're just going to return the answer, right? So let's look at the recursive call tree. So let's say for a small one, let's say Fibonacci of 3. So first, it will call to Fibonacci of 2 because n minus 1, and then Fibonacci of Fibonacci of 1, right? So we know this value because of a base case. This will just return 1, right? And this will go even deeper. Now Fibonacci of 2 will call itself, and it will be like Fibonacci of 0, and first it will be Fibonacci of 1, then 0. So it doesn't really matter. We're basically calling Fibonacci of this is Fibonacci of n minus 1, and Fibonacci of n minus 2 would be this Fibonacci of 0, right? So now this will get the addition of these two, which will be 1. 1 plus 0 will be 1. We know Fibonacci of 1 is 1 and Fibonacci of 0 is 0. So 1 plus 0. Now we have 1 in here as an answer, and Fibonacci of 1 is 1, and we have 1 in here. So Fibonacci of 3 will get the addition of Fibonacci of 2 and Fibonacci of 1 in the end, so which is basically this, and then we'll just get 2 as the answer because 1 plus 1 is 2. I mean, if you know basic math. So yeah, that's how recursion actually works, and if you need to go deeper into it, please check out my videos on the same. So let's see if it is working. Fibonacci, let's just print it. Fibonacci of 5, let's say, would be 5. and we just did Fibonacci of 3, so it'll be unfair if we don't test it out in here, and it should be 2. And let's test out another one, which was 12, and I know this should be 144, and it is 144. So our recursive solution is working perfectly, but just so you know, it's not the most time efficient algorithm because we're calling so many recursive calls, which is not very good. And I don't want to go into deciphering the time complexity of this in this video, but just know that this is not the most efficient algorithm. Now let's go for the second algorithm, which is better. I mean, it is really better. Just the iterative solution, and it uses less space. I mean, the recursive solution doesn't use any space. I'm talking about in general. It uses constant space, and it also utilizes often time complexity, right? Now let's try to kind of code it up. Now, I shouldn't have deleted that, but we'll take the same argument, and just for the sake of it, we're just going to return if n is less than or equal to 1, because we don't want to do anything. This is not the base case. This is not any recursive call. We're just doing it because why not, right? So in case we are asking for f of fib of 1, we just return 1. F of 0, we return 0. That's what it says. Now, what we're going to do is we're going to have, now before that, we need at least 2 elements to begin with, you know, to construct the later Fibonacci series, right? So then it will be 1, because the addition of these two will be 2, addition of these two will be 3. So we need at least 2 elements to start with in order to construct the whole thing, right? So that's what we're going to do. We're going to initialize 2 variables and declare them as 1 and 0 itself. So A will be 0 and B would be 1. So we have our 2 elements to start with. Now what we're going to do is we're going to run a loop starting from 2, because we're going to start from the third index, which is 2. So for int I is equals 2, and we're going to run till n and I++. Then what we're going to do is we're going to make b the answer. So before that, we're going to have to initialize. By the way, we can put it, you know, not in the scope, because then it's just, you know, initializing it every single time, but you can avoid this. I'm just going to do it to keep things simple, right? So temp will be equal to b, because we need to store b, because we're going to be changing b. So b plus equals a. So what do we know? We know that fib of n is n minus 1 plus n minus 2. So b is basically becoming the answer, because b is becoming the answer, b becoming the addition of b and a. So this is the same as, so if you, to make this even more clear, b is becoming b plus a, right? So b is becoming the answer, right? So we can write it as b plus equals a. So very simple. Now a will become b. A equals temp, because b has been changed to this, so we don't want to do that. We just want to, that's why we stored b in temp, right? And then b, we're just going to return b. So what did we do in here, right? So let's take a small series, 0, 1, 1, 2, 3, and then 5, right? So a and b is this right now, and now after one iteration, b becomes a plus b, which is 1 itself. So b becomes this, which is the answer of of 3, Fibonacci of 3. Fibonacci of 2. And what a becomes is a becomes the initial b, which is this in here. A becomes 1, 2. So a becomes this, right? Now in the second iteration, what it does is b becomes the addition of a and b. So b becomes 2. So b is basically becoming the answer every single time, and a becomes the previous b, which is 1 again. And now it keeps on repeating itself, so b becomes 3, a becomes this, and then b becomes again the answer, a becomes this, and you get the point. So that's how this works. And at the end, b will be the answer, and we'll just return b. Right? Very simple. Now let's see if it's working. Fib of 5, let's run it. And it's working perfectly. Fib 12, and it is working again. So this method also works, and it is very efficient. Now let's look at the last method. It is dynamic programming, and it uses a little bit of space, but it is very similar to the last method, and we're going to see how it works, right? We're going to utilize the same concept, but we're just going to store the answers in an array. Now, so we don't need this. This will remain the same, because why not? Now, we're going to initialize an array. We're going to call it fib, and we're going to have the size as n plus 1, because we need 6 elements to get, let's say we need fib of n, we need 6 elements to get the Fibonacci of 5, right? So we need n plus 1 elements to get the Fibonacci of n. So that's why we need the space of n plus 1. Very simple. Now we're going to declare the first two elements as we did in the previous section. So Fibonacci of 0 would be 0, and Fibonacci of 1 would be 1. So we can construct the later sequence, right? Now we're going to run a loop as we did. So it's going to start from 2, and it's going to end at n. And then what we're going to do is we're going to fib of I equals fib of I minus 1 plus fib of I minus 2. And then we're just going to return fib of n, because there we'll have our answer. So what did we do, right? So basically we initialize the first two elements, and by that we're starting from 2, and we're kind of populating the whole array. So let's go over the first few loops. So fib of 2 would be equal to fib of, this is 2 minus 1 will be 1, fib of 0, right? So we know those already. So we'll populate fib of 2, which will be 1, right? So 0 plus 1 is 1. Then we'll go to 3. So we already know fib 1 minus 2, which is 2, we just got. So this will be fib of 2 plus fib of 1, which we already declared. So that's how it will basically populate the whole array. And at the end, fib of n, let's say, which is 5 in this case, or 12 in this case. So fib of 12 will be fib of 11 or fib of 10, which will already be calculated from the loop, right? So that's how we'll have our answers. Now let's say fib of 5, it will be, what did I do? Did I write fin instead of fib? Come on. So we have 5, and then we'll do for 12, and we have 12. So yeah, our program is working. So yeah, guys, that was it. I mean, this solution was very similar to the last one, just that it's using an array and it's using open space, right? So yeah, if you like this video, please subscribe and leave a like, also leave a comment, and have a great day, guys.